everyone, we're from BMID s1k2. Today we're going to discuss a few questions that we've received from Set 2 for the subject statics, which is under Dr. Ridwan. I'm Pamitra Rangana and my metric number ends with 043. This is...
I am Pavitra and my matrix number ends with 09.
And I'm Hanifaika and my last 2 digit. My number matrix is 36.
And I'm Lunari. My matrix number ends with 38. And we have one more members, which is...
Hi. My name is Nazira. I'm from s1k1, matrix number 521.
So for set 2, this is the first question. Determine the force in each of the members of the truss shown. State whether each member is in tension or compression. So the first thing we need to do is, as usual, we will need to draw the free body diagram. So this is the free body diagram, and then we will label all the force given from the question, and also we will and also this one. Also, we will be labeling all the forces that is applied on point B and point K. For point B, it is a roller, so it only has one forces, which is BY. And also for K, it is a pin joint, so it will have 2 forces, which is KX and KY. So next, for this question, we will be using the method of joints. It is stated that in the method of joint, if the entire truss is in equilibrium, then each of its joint is also in equilibrium. So, to use this method, we will always start at a joint having at least one known force and at most 2 unknown forces. So, from this free body diagram, we know that point K has more than one unknown. So we will use the EOE method. Which is Fx is equals to 0, Fy is equals to 0. Sum of Fx, sum of F, and also sum of moment is also equals to 0. So we will start off with finding the moments at point K. So we will get 36 times with 2.4, which is this one, 36. We will take from point A first, and then we will take the perpendicular distance, which is this distance. We know it is 2.4 meter. So 36 times with 2.4, and then we're going to plus with 20. 20 is this force. And 9 is this distance, because this distance is perpendicular to 20 kilonewton. And then next is 20 times with 4.5, which is this distance and these forces. So next is BY times 13.5. And then we will calculate all of this, and then we will get BY is equals to negative 26.4. But to write the last answer, we will just write 26.4 kilonewton, and then the negative we will convert it to compression. Thus, we know that the moment at K is a compression because we get the negative. And then we're going to proceed with the next EOE method, which is sum of Fx is equals to 0. And then we will just take the from the free body diagram, we will just take the x-axis and equals it to 0. So we get negative 36 because it is going to the left side. So it is negative 36 plus with kx. And then we can see in the diagram there's only 2 x-axis, which is 36 and also kx. and then we're gonna plus both of this, and then we will put it equals to 0, and then we'll get kx equals to 36 kilonewton. And then next EOE method is using the sum of Fy equals to 0. According to the free body diagram, we know that there's 1, 2, 3, 4. There's four things at y-axis that we need to focus on, which is just now we already get by, which is 26.4, and then we will plus it with 20 kilonewton, and also this one, and also one more, which is this one, ky. So we will substitute by into the equation, and then we plus why this both is negative is because it is going downwards. When it is going downward, it is negative, and then we need to plus it with ky equals to 0, and then we put this in calculator, and then we will get ky equals to 13.6 kilonewton.
Okay, for this section, we use method of section to find here. So in order to find FGI, we use this formula, which is tan inverse, and we put here value for this opposite value, which is 2.4 over 4.5, and we get the answer 28.072. Next, we find the summation moment at J, and we know that summation moment at J is 13 times 36 times 2.4 equal to FGI cos 28.072 times 2.4 here, and we got the FGI is 14.80, which is, if the value is in positive, we will assume it in tension, and we will assume it as tension force. If it negative, we will assume the force is in compression.
Okay, in set 2, question 2, it mentions determine the reactions at C and D and all the forces at A and B. So A and B is here, C and D is here. So this is the diagram that's provided.
So what concepts did we use in this question?
Okay, so the concepts that were mainly important in this question is to remember our EOE. So the main three masters of the equation of equilibrium is sum of moment equals 0, sum of fx equals 0, and sum of fy equals 0. So that's what we used in order to solve this question and determine the reactions at C and D and all the forces at A and B. And we've resolved this into an FBD. So as you can see here in the diagram, this are pin joints. Therefore, we've resolved it into two forces, two unknowns. Same goes to point C as well. We've included the distance in it, and we've also resolved the pin joint that's at point B and also at point A. And we've also stated the weight, which is the force, which is 80 kilonewton. Okay, first step in the solution is to resolve the pulley that's in the diagram that's provided. The pulley is also known as a pin joint. Therefore, we've resolved it into AY and AX. So when we use the equation of equilibrium, we can clearly see that EFX equals 0 and EFY equals 0. Therefore, AX minus AT equals 0, which makes AX equals to 80 kilonewton. Same goes to sum of Fy equals 0, Ay minus 80 kilonewton equals 0, which makes Ay equals 80 kilonewton.
Now let's resolve the FPD. We find the AX and AY for the pulley, so we can resolve these two separate FPDs. We resolve this to make it seem a bit more simpler than it's being complicated. So this is the diagram from here to here, from A to C, and this is the diagram from B to D. So to find each other's moment and the value for Bx and By, we have to do at the same time. So let's look at this diagram first. We are going to do movement at C, point C, because there are two unknowns. And since Bx and Cx on the same line, we don't have to include Bx. So the movement at C will be 80 times 5, 80 times 5, the distance, and By times 3. So once you calculate it, it will get By equals to 133.3 kilonewton, which we can put it over here. So it will be easier for us to find the moment. In this diagram, we are doing the moment at point D because there are two unknowns. So you have to put in the value for By and the 80 Newton. The 80 Newton, the distance is 0.8 meter because we are going to take the perpendicular distance. And for the Bx, the distance will be 3 meter. And we don't have the value for Bx, but the distance for Bx is 1 meter. From here to here, we have to just plus this. So we'll get the answer for Bx, which is 335.9 kilonewton.
Since we have been able to find the moment at point C and moment at point D, which is moment at C is 133.3 kilonewton, moment at D is 335.9 kilonewton, we are able to find force X and force Y. So here we'll be using 80 kilonewton plus with 335.9 kilonewton minus Cx. So we haven't been able to find the value of Cx. By using this EOE, we are able to find Cx, which is 415.9 kilonewton. And once we found this, we're able to find the force Y by using equilibrium of the equation of equilibrium. So negative 80 plus with 133.3 kilonewton, which is By, minus Cy equals 0. So since we don't know what's the value of Cy, it's very easy for us to find Cy equals to 53.3 kilonewton.
Okay, now let's take a look at this diagram. Since we got the answer for Bx and By by doing the movement, we are only left with dy and dx. To resolve and get the answer, we have to do the sum of fx equals to 0 and the sum of fy equals to 0. So let's take a look at this. The sum of fx equals to 0. So we are going to find dx, and to find dx, you have to look at all the forces at the x-axis. There's two, 80 kilonewton and also bx, which we already have the value for, and both of them are negative and dx is on positive. So just put it in an equation and get the answer, 415.9 kilonewton. And for the sum of fy, to find dy, just let's look at all the forces we have. We just have two, which is by and dy. We already have the answer for dy, which is 133.3 kilonewton. dy is negative since it's going down on the y-axis. So the equation will be negative 133.3 plus dy. When you move negative 133.3 from this side of the equals to that side, it will become positive. So we'll get the answer for dy, which is 133.3 kilonewton.
And the last question is question number 3. the question stated that the tongs shown are used to apply a total upward force of 45 kN on a pipe cap. Determine the forces exerted at D and F on tong ADF. For the free body diagram, we will be taking this part as the free body diagram. Force upward is 45 kN. Thus, the force at B is 45 kN and the force at A is also 45 kN. And then, to get the force at this point, we will have to divide 45 divide by 2, and then we will get 22.5 kN, which is, this is the force at this point. So now we know that the force exerted on this point, which is point A, is 22.5 kN. And then for the free body diagram, as usual, we will be labeling all the distance from the question. This one 85, and then this one is 75, and then from the question we know that it is symmetrical. Thus the distance here at the right side and also at the left side is equal. So from this question we know that the center part is 60 millimeter, and then it is given that the right side, the left side and also the right side are 25. So we will add both of this, plus 25 plus 25, and then we will get the total of 110, and then we will divide 110 with 2, so that we can get the equal amount at the right and also at the left side. So we will get 55. So that is how we know that from the point A to the center part of here is 55. So after getting the distance between A and the center, which is 55, we will also get the distance between the center and D. So we just need to add these two distance, which is 55 plus with 30, so we will get 85. So the distance between A and also D is 85 meter. Next, we need to find the distance between D to F. To get this distance, we take a look at the diagram. We know that the distance between E and F is 90, and the distance between C and D is 60. So we need to know how much is the distance, the balance here and here. So we minus 90 minus 60, this distance and also this distance we minus, and then we divide by 2. 90 minus 60 divide by 2, and then we will get 15 millimeter. So 15 millimeter is the distance between D and also F. So now at our free body diagram, we already get all the distance that we need. Which is 85, 75, 110, 15, and also 85. So next, we need to resolve the free body diagram and label all the forces that is exerted from the FBD. So we already get the first force, which is 22.5 kilonewton just now, and then we need to label at F. It has two forces, which is Fx and also Fy. At D, it only has one forces, which is FCD. FCD at the x-axis. Okay, that is all for the free body diagram.
So we have to want to calculation of the free body diagram. So we have to three methods is sum of moments, sum of Fx, and sum of Fy. So the first step we have to find of the sum of moment, which is if we want to find the moment, this is the formula. First divide of the first time of distance. So which one? This one. Okay. For the diagram, we have a two force, which is this one and the this one, FCD. So from this one to 22.5 kilonewton. Why we put negative? Because it's a this one clockwise. And for the FCD, why we put positive? Because this one anti-clockwise. Okay. So and time to distance. So the distance is 1 from we found this one, and the 75. So this one. So FCD. So the answer of the FCD of the moments we got 33 kilonewton. Okay. For the second step, we have to find the sum fx equals 0. So which one? This one. Okay. So this one we got fx and fcd. So why positive? Because fx direction is right, positive. The negative we have to the left, right, is negative, equal to 0. So fx negative with 33 kilonewton divide 0 fs. So the answer for fs is 33 kilonewton. The third step, the sum of fy. We have also three force is fy, this one, and this one. Okay. For this one, we just take this one 22.5 negative fy because fy is down, negative, equals 0. So 22 fy. Okay. So the result for at f. This the formula of the result force at f. So substitute and then we got the answer fx, this one, plus and fy, this one, the answer. Just put the formula as the given. So with calculation, the answer we will get the 39.94 kilonewton. So the final step, we have to find the angle position. Angle position, the formula we will here. So substitute tan reverse times with fy divide fx. So substitute we will get the answer 35.29 degrees.